You guys are doing, finally, we've been getting close to this. This is my favorite part. Algebraic, what did you say?
Is it hot?
No, but it's actually algebra. So, all those things that you've had to learn, finally, this is why. So sometimes we can find limits graphically. So, you know, maybe if we know the graph, we can find limits graphically, which is pretty easy. We know that we want the graph to come from both sides. It's got to match up there. A hole in the graph is fine. And sometimes we can use direct substitution. We can use it when it's a well-behaved function, like a parabola or a cubic, any general polynomial, we can do direct substitution. So there's a few things that we can do, and direct substitution is always a good step number one. If you can do direct substitution and it seems to work out just fine, then you can go ahead and do that. But if you do direct substitution and if you get something like 0 over 0, or if you get a number and it's a 0 on the bottom, you know, maybe there's something weird that happens. But if you get something where you have zeros underneath, we have a bunch of techniques that we might have to do instead, okay? The first and most easiest is factoring. Maybe we can factor and simplify, all right? This is why we've learned all of these techniques since Algebra 1 to clean things up, find equivalent things. Maybe you need to rationalize. If there's a radical, so we might have to rationalize if there's a radical in our formula. Maybe we've got to do some trig substitutions. And maybe, you know, we need to get a common denominator. Maybe because we're going to be adding fractions up and we need to do some simplifying. So maybe we're going to need to get a common denominator. All right, so these are all the different things that we do. And again, limits is great if it's a nice continuous continuous function, we can do direct substitution. But if something weird happens, we know we're going to have to do some extra stuff. So I kind of want to just skip this first slide, and we're going to come back to it at the end. So turn the page to example 3. So I want to find the limit, and again, we're practicing proper notation. So this is my function, 4x squared plus 3. What shape is it? Parabola. Is it continuous? Yes, it's a continuous function. Therefore, I can use direct substitution, ds, direct substitution, excuse me. I can go ahead and just substitute in my x value. So 4 times 2 squared plus 3. 2 squared is 4. Times 4 is 16 plus 3 is 19. All right. Here is the function continuous? No, it's not continuous. But does it matter? If I plug in a 1, am I going to get a divide by 0 problem? No. This one, we know right off the bat, x cannot equal -1. If we were finding the limit as x approached -1, we would have a problem. But because we're approaching +1, it's okay. We can just plug it right in, okay? So we can go ahead and just do direct substitution. So I am going to go ahead and I'm just going to go ahead and substitute. I don't think we need to do anything. Plugging in my 1 everywhere there's an x. Let's see, that's 1 plus 1 is 2 plus 2 is 4 over 2, which gives me 2. Not 1/2, it gives me 2. All right. All right. Boy, I did a whole lot of work on that. Okay. Next. Letter C. All right, what is x not allowed to equal here? 1. X cannot equal 1. Ooh. So because x cannot equal 1, what's going to happen when I plug in the 1? It becomes undefined, all right? And this gives me a problem, okay? Because of that, I am going to use a factoring technique, okay? It's a cubic. Yes, it is a cubic. Small bubble, big bubble. Hey, you remember stuff. All right. Yeah, so this is a cubic, and we probably haven't done this for a long time, but it's a cubic factor here. It factors into small bubble, big bubble. Do you remember that? Oh, it's been a while. Do you remember the signs on a subtraction, small bubble, big bubble? Minus, plus, plus. Minus, plus, plus. It's the same sign always, and then change the sign, always positive. Keep the sign, change the sign, always positive is how that goes, but minus, plus, plus, or plus, minus, plus. Now, what goes in my little bubble here? And a 1. It is the cube root of each of these, if they were crazier numbers, but we square the first thing, multiply the parts together in the middle, so 1 times x is 1x, and then we square the last thing. 1 squared is 1. All right? That is a long time ago, but if you want to write down the rules, a cubed minus b cubed factors into small bubble, big bubble. The signs go minus, plus, plus. And this is something cubed. We want the root. We want the base, just a, and the base, just b. And we square the first thing, a squared. We multiply them in the middle, and then we square the last thing. All right? So that is that factoring pattern. And the plus, everything stays the same except the signs go plus, minus, plus. A plus b, a squared, ab, and b squared. All right, so in case it does not come up very often, if ever. I haven't seen it on an AP test in at least 10 years. So, I don't know. Anyway, once you factor, what happens? They cancel out. So, yeah, we have a common factor top and bottom. That actually would turn into a whole graphically, but because this is algebra, we can just reduce them. They reduce to 1. Graphically, it becomes a whole. But so then we have just the limit as x approaches 1 of x squared plus x plus 1. So a simplified function, and now we can do direct substitution. So that's going to give me 1 squared plus 1 plus 1, which is 3. All right. So graphically, that became a whole, but really it just simplifies for us, and we can figure out that non-existent y-coordinate. Really weird. All right. This is interesting. Here's my function, x over x minus 2. What is x not allowed to be? 2. And how come? Yeah, 2 minus 2 would give me 0. So that we can't have a 0 underneath, okay? So this is interesting. We want the limit as x approaches 2 from the right. What's happening graphically for this function?
What I mean?
What's happening graphically?
Like, what's it look like? It can't be negative. Or it can't be. Like, it's coming from the right. I know that.
Yeah, it is sort of like a gang sign one, sort of. Yeah. Does it has a vertical asymptote. At x equals 2. And we only care about the limit coming in from the right-hand side. So what we have to figure out, well, is our asymptote, is our function then going towards positive infinity, or is our function going towards negative infinity? This function does not reduce, it does not simplify, I can't clean it up at all, so the only thing I can do is a numeric technique, all right, to figure out my limit. I am going to choose a number slightly larger than 2. What is a number slightly larger than 2? 0.001. I'm going to go 2.001. So we're going to test the value and just see what happens. 2.001 and then 2.001 minus 2. So I'm trying a value and testing, and we're going to see what happens here. What is 2.001 minus 2? 0.001. Okay. So on top I have 2.001 divided by 0.001. Okay, but wait. This is a very small number, isn't it?
Yep.
Yeah. And in fact, I could say this is 2.001 over, let's see, this is 1/1000th. Okay, 1/1000th. That is the name of this decimal because it is the fraction 1 over 1,000. And you could check if you want, but 1 over 1,000 is 0.001. Okay, so what happens when I divide by a fraction? You multiply by the reciprocal, yeah? So this becomes 2.001 times 1,000 over 1. And this number just got 2001. It got huge. Yeah?
Oh, yeah.
Yeah, it got huge. Okay. So that means it's going to positive infinity. And I could try a different number. I could have done 2.0001. But again, when we're dividing by something super tiny, it makes our number huge. Okay? And this is the math that we flip the fraction. All right? So dividing by a decimal makes our fraction very, very huge. So this limit is going to go to a positive huge number or infinity here. Okay? Do you have questions on that one? All right. All right. I don't want to answer this one right now. It's not the same as C. So turn the page. All right, so these are the real algebra techniques that you come across. What do you notice about these functions? They've got square roots in them. You'll also notice rational fractional. What is x not allowed to be? X cannot be 4. Again, so what happens if I were to try direct substitution? I would get undefined if I plugged it in, right? Okay. Because it's going to go undefined on me, I have to think of a technique that will help me simplify this. And this is the rationalized technique. All right, the rationalizing technique. This is a conjugate. We have two terms here. We have to rationalize by multiplying top and bottom by the conjugate. That's going to get rid of the radical for us, which will be helpful. What is the conjugate of the square root of x minus 2? Plus 2. Yeah, square root of x plus 2. So we're going to multiply top and bottom by the square root of x plus 2, which can get complicated, but this is the math. So we're going to go ahead and FOIL these two things together, and we're going to see what happens here. So I still have my limit notation. All right, in the numerator, I'm FOILing. What is radical x times radical x? X. And the outside becomes 2 times radical x, so that's positive 2 radical x. And the inside becomes negative 2 radical x. Ooh, I just read, yes, that's why we do the conjugate. And then last times last would be negative 4. Negative 2 times positive 2 is negative 4. So you can see when we use the conjugate, the radical disappears for us, and that's very nice. Now, on the bottom, I'm actually going to go ahead and not multiply the bottom together, and you'll see why in just a second. I'm going to leave, the radical wasn't really the issue. It was actually the thing, that denominator problem. Let's see what happens now. Yeah, so now what's left on top, I have an x minus 4. And on the bottom, I have the x minus 4 bubble and the square root of x plus 2 bubble. Yeah, so these now happen to reduce, and my problem has disappeared. I'm left with the limit as x approaches 4. What's in the numerator? No. Oh, you failed math. What's left in the numerator? 1. Yes. Remember, they don't just go away. They reduce to 1s. All right, and in the denominator, we have radical x plus 2. Now, we've done our algebra technique, and now we can do direct substitution. So we can go ahead and just substitute in our value because we have simplified our function. So square root of 4 plus 2. What is the square root of, 1 over 4. So there we go. That is our... What? I think that this is fine. Remember, you can skip 2 steps, but not 3. Okay. Okay, questions on this one? Okay. So this is similar, but slightly more complicated. So, gentlemen, are you paying attention? Because you start talking a lot. It's distracting me. All right. Again, what is x not allowed to be? 0. Okay. And because it's not allowed to be 0, when I go and I try to direct substitute, I try to plug it in, I'm going to get something undefined. If I get something undefined, I need to think of an algebraic technique to help me clean this up. So we're going to rationalize again with the complex conjugate. So I'm going to multiply top and bottom by something. Now this is very tricky. What is our complex conjugate here? Very good. The square root of x plus 1. So the radical stays the same, and we change the sign between the terms. All right? And then top and bottom, square root of x plus 1 plus 1. All right. So once again, I'm going to FOIL my numerator together, but I'm going to leave the denominator in bubbles. So I have the limit as x approaches 0, and my numerator, what is the square root of x plus 1 times the square root of x plus 1? Just x plus 1. The radical goes away. The outside is 1 radical x plus 1. I guess I'll write it down, but 1 square root of x plus 1. And the inside is minus 1 radical x plus 1. Okay. And then last times last is negative 1. My denominator, I have an x times the square root of x plus 1 plus 1. Again, you can see that complex conjugate, those middle terms cancel out. They're going to cancel out every time. Do you have to write them down?
Yes.
No.
Heck no.
Heck no. That is definitely math you want to skip. All right? I'm showing it in notes just so you can see what's happening. All right, I'm going to do a little cleanup here. The limit as x approaches 0. My numerator now is what?
X.
Just x. And on the denominator, I've got my x and radical x plus 1 plus 1. What happens? Reduce, reduce, and Colt, what's left?
1 over.
Ah, very good. He learned. All right, 1 over square root of x plus 1 plus 1. Now that we've cleaned things up, now I can do my direct substitution. So I'm going to get 1 over the square root of 0 plus 1 plus 1, which turns out to be what?
1/2.
1/2 as our final answer. Okay? Questions on that one? No, not good. No, not quite. Yep. All right, so these are going to be the last two for now. All right. When we look at this is a complex fraction. All right. Complex fraction. Can I plug in 0?
No.
No, we get something undefined. So this is one where we're going to need to clean up our fraction. So we need to get a common denominator. All right, so make our fraction come together. So just looking at the numerator, I need to make our denominators match. I have a denominator of x plus 3, and I have a denominator of 3. What should I multiply the first fraction by?
3.
It needs a 3.
3, I think.
On top and bottom. All right, this one has the 3. What part does it need?
X plus 3.
It needs the x plus 3, top and bottom, so that they have the same little factors. So I'm going to rewrite that. So now my numerator, it has a common denominator of 3 times the quantity x plus 3. My numerator, I've got the 3. 3 times 1 is 3, minus, this is minus. I have to distribute. Oh, that's really hard. It's a minus 1 quantity x plus 3. I'm going to write it like that just so you're clear what's happening here. It's a negative 1 times the quantity x plus 3. Watch that negative. It'll kill you every time. All right. Well, they can't yet. We're going to do a little bit of math first. All right. So I'm going to distribute my negative because that is the thing that, every time. Negative 1 times x is negative x. Negative 1 times 3 is negative 3. Over 3 quantity x plus 3. And my denominator still has an x in it. Are you with me so far? Yeah? Okay. Limit as x approaches 0. I have a 3 and a minus 3. What happens with those? Oh, they cancel out. Okay, so I just have negative x on top over 3 quantity x plus 3. And that's being divided by x. Wow, I still have a complex fraction here. Boy, that looks weird. So I have a fraction on top. Can I have a fraction on the bottom?
Yeah.
Yeah, okay. So that's like an x over 1 if I want to do it that way. Multiply by the reciprocal, yep. So we're going to multiply by 1 over x to get rid of that denominator. And so that gives me the limit as x approaches 0 of, what happens then? Yeah, I can do this in one step here. The x on top and the x on bottom here are going to reduce each other. So that's really nice. And I have a negative 1 on top and 3 quantity x plus 3 on bottom. All right, are you with me?
Yeah.
Yeah? All right, now we've cleaned it up. Now we can do some direct substitution. So now I can go ahead and plug in my 0. Negative 1 over 3, quantity 0 plus 3, which is? Negative 1/9.
Do I, like, if I'm showing my work, do I have to write the limit every time?
You have to write the limit? Yes.
Every time?
Yes.
Oh.
Until you do the direct substitution, you have to carry on the limit notation. All right. What do we do on H?
Probably find the,
Can we plug in? Is there any reason we couldn't plug in?
no.
Okay, let's just plug it in. So sine of pi times 2 over 12, which would become sine of,
1/6.
yeah, 2 over 12 reduces, right? Yeah, pi over 6. All right. Pi divided into 6.
Wait, let me use mine.
1/2. All right.
Good job.
1/2. It is that little short leg there on our little triangle. 1/2. Okay. These are the techniques you're going to be practicing on here. Your worksheet is on the next page.
Look good now. You give us like 30 periods.
I already looked, I couldn't find them, I thought they were in my binder, I thought it was